you or one of your interests. So my name's James Dwyer, and I'm one of the 2 LEGO certified teacher trainers at Modern Teaching Aids. The other teacher trainer is Joanna Burke, who's on the chat function. And yeah, so she'll be there to answer questions while I'm presenting as well. As I said, we've also got Chris Todd, who's one of the Queensland reps, and he's on the chat function answering questions. Okay, so to give you an idea of what we'll be covering during today's webinar, we're going to be showing you the Spike Prime kit. We'll have a look at the sensors and the programmable hub and how you might use them. We'll review the software. We'll explore the unit plans and how LEGO Education have set those out. We'll demonstrate one of the units with the super cleanup, and we'll demonstrate some scratch-based programming so you can, to help you get started if you're not familiar with it. We'll also review some of the online support materials that are available. And as I said, we'll have a Q&A session at the end. Okay. Now, Spike Prime is a really nice addition to the LEGO Education product family. Now, it's targeted from the years 5 through to year 8. And I guess from its very inception, it's really been designed with LEGO Education's core philosophy in mind, and that is that play is essential to learning and building confidence. Now, that philosophy itself is based on Seymour Papin's theory of constructionism, which is the idea that children learn best when they are actively engaged in constructing something that has a personal meaning to them, be it a poem, a robot, a sandcastle, or a computer program. As teachers, we all intuitively know that it's optimal to have kids engage in hands-on and playful activities. So now, I guess LEGO Education have an understanding of what they mean by play, okay? And in this case, their sort of research they've essentially boiled it down, the play down to 5 characteristics to make it meaningful and educational. And the first is it has to be joyful. If students find the learning joyful, they're indulging their curiosity, they're intrinsically motivated, and they'll take ownership and initiative in their learning. And we all know those sort of cases where you've got students in the class, and we experience it at the workshops that we run as well, where it will be lunchtime or time to pack up, and you sort of got to take the kits out of the teacher's hands, or in your case, the students' hands, because they're just that actively engaged that that they just don't want to leave. They want to keep working, and that's a great situation to be in, or a great problem to have, if you like. The other thing is the learning needs to be meaningful for the students. It also has to, as I said, they're actively engaged. It's hands-on. They're really sort of mentally and physically engaged in that sense, building things with their hands. It's wonderful, as opposed to it just being a cognitive process exclusively. Then we've got that the activity should be iterative. They should be going through, trying different things, having success, having failure, trying new ideas. It's that sort of experimentation which is really critical to their learning. And it needs to be socially interactive as well. And for that, we've got the ideal scenario is that the kids are working in pairs, that there's one kit per pair of students, so that they're working together and inspiring each other and helping each other along. Okay, the concept behind building the Spike Prime is, at its very core, is it's helping to build student confidence and teaching and their learning with in robotics and robotic education. And so from the very outset, the whole idea has been about giving the kids the confidence to develop those skills. Okay, so we'll get started and we'll have a look. The first thing we've obviously got the 2 parts, if you like. One is the Spike Prime set itself, and the other is the Spike Prime app. Okay, and we'll jump in. First of all, I want to go through some of the hardware, and then we'll have a look across at the app after that. Okay, so the hardware, if we're introducing it, this is essentially the LEGO hub. It's the smart hub. You can see it's designed, for those of you who are familiar with the EV3, that sort of thing, this is designed in its small little compact sort of rectangular shape. It's easy to build with in comparison with some of the other bricks and things, and you'll find that with the motors as well. They've gone for that really easy to clip together sort of package. It's also got a lot of sort of connector points on the hub itself, making it easy to attach motors and sensors and that sort of thing. You've got the points of contact. You've got you've got a little standard micro USB connection there where you can plug it in to the computer. It's also how you can charge the rechargeable battery that comes in it. So no longer can you put in AA's. So environmentally, this is a wonderful addition, okay, that all bricks will have the rechargeable battery and be using that. And you've got then 6 ports as well, okay. Now, no longer, for those who are familiar with the EV3 again, no longer do you have specific ports that you use for sensors and specific ports for motors. You can plug any motor into any port or any sensor into any port. So in theory, you could connect up to 6 sensors or 6 motors if you were combining them from different sets, that sort of thing. Okay. In addition, you've got a little speaker there that can, you know, play sounds, and you've also got, and I'll just turn it on. You turn the large button at the bottom, allows you to switch it on. And then you've got a 5x5 matrix on there to display numbers and words and images and that sort of thing. All right. So we'll jump in at this stage and I'll jump into the software. Bring that up. Whoops. Okay. Okay. So the reason I'm going to bring up the software, I'm going to show you some of the, this has also got a sensor in it. It's got a gyro sensor in it that we can use as a, in our programs. So if I jump in here, at this stage, I just want to jump straight into a new project. Okay. You've got in there, okay, in this section. And the brick itself can be connected up. So if you just, I'll just cable connect it. And I'll draw your focus up here. This should turn from red to green, and it just did, and it gives you an indication that the hub's now connected. Okay. If you double click into this, you can get information about the hub. And it should, oh, there we go. There we go. Okay, so in here, it tells me what hub, you know, I've changed the name of the hub. You can come over here to these 3 little dots down here, click on that, and you can see the ability to rename the hub, okay? Which is really handy if you're Bluetooth connecting to 10 different hubs in the classroom. Then you'll want to name them all individually so that kids can identify which hub they're connecting to. Okay. You've also got here on this dashboard section where you can see here this yaw, pitch and roll. As I said, the brick itself is a sensor. And as I turn this, you can see that the numbers are changing. So the yaw, the pitch and the roll. Now, for those who are familiar with flying drones, that sort of thing, those are the readings, if you like, that can determine whether the drone flies forwards, backwards, or rolls to the side and the direction it flies in 3-dimensional space. Now, if you're not familiar with that, you can come down here to this orientation, and there's a much simpler way it can be used in your programs. You can just change it to orientation, and it will determine which side is up. So you can see at the moment, I've got the hub facing up. If I put it on its side, you can see I've got the left side facing up. If I turn it the other way, it'll have the right side facing up. So you can use those sort of things, or the top, or well, in that case, the bottom is up. In that case, the top is up. Okay. So you can use those sort of things to get feedback about the position of the robot, or where the, whatever you've created, which way is facing up. And you can use that to change the behavior of the robot itself. In here, we've got manage programs. And in here, you can see we've got 20 different slots that you can load up programs into. And that's from 0 to 19. Okay, so you can see in here, I've got a single program in this particular brick. It's called, the program was named Project 1. You can see how long ago it was loaded in 20 minutes ago. and you can see the date it's created, and you can delete it and manage files in here as well. And you can see it's loaded into slot 0 at this stage. So if we jump back, okay, we can now start introducing other sensors and things. All right, so at the moment, I've just picked up the distance sensor, okay? So I'll plug it in, and if you have a look up near the green section, you can see as I plug it in, it pops up here, and you get a little readout of directly from the sensor, a live feedback about how far away objects are. And you can see as I move my hand closer, that number is changing. It's currently telling me my hand is about 10 centimeters away from the object. You can move it closer, that sort of thing, and further away. Now you can use that sensor obviously in your programs to create robots that might sense whether they're moving close to a wall or an object and change the behavior of the robot in that way. You know, I've seen examples on the internet where people have created hand sanitizers, that sort of thing. So if you just wave your hand underneath it, it'll pull down on the hand sanitizer and give you a squirt of hand sanitizer or soap or whatever's loaded into it. So there's all sorts of ways that can be used. In real life, we see these used in our cars that reverse up, and they'll beep as they're reversing, getting close to objects. You'll see it in airports where, you know, you put your hands underneath the taps and they start working automatically, those sort of things. So these sort of sensors are used all over the place, and your kids can simulate that with, you know, in their robotics classes, if you like, whether it's doors that automatically open as people approach, all sorts of ways they can be used, which is really cool. Okay, some of the other sensors, I'll grab out this particular sensor, and you can see as I plug it in, it pops up there. Now, another place you can view the feedback from sensors is if I click back in there, you can see here, it can tell me which ports things are connected to. So at the moment, I've got an ultrasonic sensor connected to port A, and I've got a pressure sensor or pressure sensor or force sensor connected to port E. So you can see as I press it, at the moment, it appears to read on, but that's 0 newtons. So I'll press down a little bit on it, and you can see that changes. At the moment, I'm applying 4 newtons of pressure, and I can increase as I push down more and get different readings up to a maximum of 10 newtons. So you can get a reading anywhere between 0 to 10 newtons on that particular sensor. Okay, so you can incorporate that in. You know, previously in say with the EV3, the touch sensor was just a direct on-off, whereas this will give you degrees of how much pressure has been applied, and you could use that to control the speed of motors, all sorts of things. So if I'll jump back in, we'll connect up another sensor. Okay, in this case, we'll connect up the color sensor, and you can see as I plug it in, you can have all these sensors just connected live, and it comes up here, and you can get a reading. You also get a reading if I drop back to this section, it's popped up here as well. So just drop back in because it might be easier to see in here. Now, depending what color I wave in front of it, you can see I've grabbed a blue brick. If I put it in front, it can tell that there's a blue brick in front of it. And we can use that to code our robots or constructions as well, designs. Okay, it's red, green, that sort of thing. Okay, you can also use it if you come through here. There's other options to use it in reflected light mode. So it will to tell you what percentage of that light is reflected back into the sensor as well. Okay, but that for the moment, you can just think of it in color mode. It's sort of the easiest way to learn, if you like, with it. Okay, so if we jump back, okay, now next thing we can do as well is we can plug in motors. So you've got these little, I might just unplug a couple of these sensors while we're doing that. Okay, and we'll come back. We've also got motors as well. So we've got 2 of these medium-sized motors and a large motor as well. And you can see I've attached a little bit of Lego to that at the moment. So that's the large motor. One of the nice things about these motors is they've got a 0 setting. So they've got an encoder inside them. I'll just plug it into the brick itself. Okay. Okay. You can see here, okay, you've got a reading. Whoops. It helps when you actually plug the sensor in. We'll get that. There we go. And you can see now I've got a reading on here. I'll swap to here. You can see as I turn this, you can see it's changing. It'll give you a feedback of how many degrees it's being turned in a positive or negative direction. Okay, so you can turn it get it to 0, turn it around a full 360 degrees. All right, and so we can have it set back to the 0 point, and I'll show you that in the program in a moment. Okay, so all right. Now if we jump back into the program. So if we were to start programming this particular block at the moment, I'll dive in now and we'll go through the software in greater detail and the sort of setup and the structure in a moment. But first of all, while we've got the hardware out, if you like, we'll have a little play and I'll introduce the Scratch-based programming that Lego are using. Okay. So when the program starts, what you have is these sort of, you're creating stacks of code and you're using these blocks here to drag out and create stacks of what to do, whether it's to display things on screen, that sort of thing. Okay, and so it will go through, it will start with what these are known as hats, and that's where events will trigger the stacks of code, if you like. So in this case, it will, when the program starts, it would execute this block, then this second block underneath it, then the third block. Okay, now you can just take it, if you're not wanting a particular code, you can just bring it over here and trash it, throw it away. Okay, so the first thing we might do is just set this up when the program starts so that it will take the shortest route to whichever position it's, to the 0 position. So it's pointed down, okay? So you can set it up to turn clockwise to that position, anti-clockwise, that sort of thing. You can come in here if it's connected to a different port. So I just I'll connect it into that port at the moment. And you can see it's giving me feedback. I'm talking about the motor connected to port A. There is no motor connected to port A at the moment. It's connected to port E. So I'll just click on that and change it. And next thing, okay, it's now set up correctly. Now, to run this program, you can come down here. If I don't want to put something on, you remember I showed you there was a program sitting in position 0. If I want to put it into a different program, so let's say I want to put it into slot 2. I've now changed it to bring that up. I clicked here, it brings up slot 2, and then I can just come in here and press play, and you can see the program started and it put it into the 0 position. That's 0. So if I wanted to set it at 90 degrees, I could just move the dial, but sometimes if you want to be precise, it's easier just to type it in and run that program again, and you'll see it'll move. I'll run that, and you can see it moves to position 90. Okay, so now I want to start using the color sensor, so I'm going to connect that up. I'll put that there. Okay, so you can see I've attached the color sensor to the side. Now I want an event. I want one of these caps to do something when that a bit of code, whenever I put a blue block in front of it, you can see nothing happens. Okay, so we've got a code, put some code in. I'll grab one of these blocks. Okay, and you can see by default, because there's only one color sensor, it's detected and it's put in that it should be on port D. It's done that. Okay, now it's red, so I want it to, on the screen, I'm going to display on here, I want it to display some text. So we're going to put in, okay, I'll clear this and make it so it's just going to display red. Okay. Okay, so it's going to be R for red. Okay, and then I also want it to play a sound. So I come down, grab the sound. I'll grab this cat meow. Okay, so when a red color goes in front of it, I want it to display red. And I'm going to get the motor to move as well. So I'm going to grab this block and I want it to move for 180 degrees. I changed it from rotations. You could have it move for time. You could have it, if these are the options here, you could have it move for, the default is 1 rotation. I've changed it to 180 degrees and you could have it move for seconds. It's going to move in that clockwise direction. Now, if I want to have a different behavior, I can come here and I can duplicate it. To bring that menu up, I right-clicked, duplicate, and I've got an exact copy of that. But this time around, I don't want it to do the same thing based on red. I want it to do something different if I get it to show it the blue color. So I'll come in here, I'll change this, and now it'll display a B. But I don't want it to say the same sound either. I'm going to change the sound so we can jump into the sound menu. So I'll come down here. So rather than the cat meow, I'll add a sound. Bring that. You just hover over the sounds and it'll play them and you can determine what sound you want. I might grab that basketball bounce. So I'll grab that and you can see you can even edit the sound if you want it to be shorter, that sort of thing. But that's perfect as is. I'm going to grab that. You can record sounds as well if you choose to. Okay, and that will be fine. So that should be here, and there it is, basketball bounce. So if I run this program, okay, now you can see it moved to the position. Or, okay, if I wave a blue in front of it, I get the B, and it spins the 180 degrees that it should. Whoop. Okay, now if I grab the red, oh, wait a minute, we've got, one of the things I haven't done is change them, so I'll stop that program. So it's, oh, and it's upside down as well. We'll correct that so it makes more sense to you. But the other thing I'm going to do is stop that program and modify it. So I'll hit stop and I'll come in here, and rather than having this one go in the same direction, I'm going to have it go counterclockwise and something that will be visually different, 90 degrees. Sorry. So we've now got this one going, when it's red, it should go clockwise for 180 degrees. When it's blue, it'll go the other direction for 90 degrees. So modify it. You can see it went back to 0. No, it went to 90, sorry. And you can see for blue, and it's turning 90 degrees each time. If I wave the red in front of it, it goes the other way. And if I wave green in front of it, it does nothing. Okay. So you can see that's the sort of simple coding style that's available to students. Okay. And you can see all the blocks are broken up here into, there's motor blocks if you're trying to control a single motor. There's movement blocks if you're pairing them for a vehicle or something, if you're you want 2 motors to work together. Okay. Then you've got light blocks for displaying things on screen, sound blocks, events, or those sort of hats that we're going to start our events with, or, you know, under a particular code. And so you've got other control things here if you're trying to create loops, if else statements, those sort of things. And you can just sort of make your way down. There's, for those who are familiar with Scratch, there's all the sort of ability to control sensors and operators that will allow you to add and do mathematical things with the code that's there. So it really does open up quite a lot of learning opportunity for students, which is wonderful and makes it really easy to access. Okay, so that's the sort of the hardware, if you like. There's the Scratch programming. What we might do now is jump into the the software itself and have a look at what Lego Education have done to make or give you some structure and lessons that you can really work with and get your teeth into, which is great. So if you jump back to this home page, okay, and this is, okay, the lobby, if you like, or where you first start. And you've got the 5 tabs along the cross. There's this home, start, units, build, and my projects. And there's a number of different ways you can access that. But so, for example, there's the start button here is the same as the start there. Unit plans, you can click on this or click up here. I generally just use the 5 tabs across the top, but it's up to you, whatever makes sense. So you can scroll down. So if we jump into the start, this is the section when you first get, opening up the kits, if you like, and having a look at them, and the kids are just getting started. You've done the unpacking, and now it's, the kids are ready to sort of learn. You can jump in here, and there are little activities to get you started, and just an explanation. Sorry, it's a tad slow. They've just done an update recently, and it's working slightly different to the previous version. Okay, so you can jump in here and you can see there's a little tutorial on getting started. Introduces you to the hub and, putting the battery together, inserting the rechargeable battery, that sort of thing, basic programming. And you can see here, you've got a very limited palette, if you like, of blocks. And they've done this intentionally to make it easy, to ensure that you're not getting lost in that myriad of blocks that I was showing you earlier. Okay. So we've got here, and it's basically telling you to drag that out and teaching you how to get started with Scratch-based programming. So it starts very easy and then allows you to get much more complex. And we can jump into that. And now it's telling you to play that. And you can use this particular, brick here, and it'll play that. And there's the happy face that's displayed on the screen. Okay, so there's basically a guide there to walk through all the different sort of tutorials there. So I'll just jump back here. So that's in the start. Okay, I just took you into this section and you can walk through. There's a whole lot of steps. I won't take you through it now. We've only got a short amount of time. Then we've got the motors and sensors, and this is where the kids would build some little functionality around the motors and sensors and get them combining those with a bit of code, such that when you press the button, it'll do things with the motors, that sort of thing. And then there's a fun little activity there called Make It Move. And that's one where you're trying to create a little robot, trying to get it to move without wheels. And you can have a lot of fun with those sort of things. And it's very iterative, where the kids will go back and relearn or improve and take ideas that other students have implemented and to improve their design. And it's a fun activity. And I'll show you a little video of that. We do it sometimes in the face-to-face workshops, and you can see it's a lot of fun. Okay, so that's the start section. Then we jump into the units themselves, okay? And they're broken up into these sort of 4 areas, if you like. There's Invention Squad, Kickstarter Business, Life Hacks, and Competition Ready. Now, there are about 30 different units inside these, and we'll go into them in a little bit more detail because we'll go into it in a moment. Actually, we might jump into Kickstarter Business quickly, okay? And I'll take you through the setup, and then we'll jump back into one of the ones that I want to take you through in a moment. So Kickstarter Business, the idea is it's trying to encourage entrepreneurial skills, if you like, about starting a business, but it's also in the goal in this section is developing computational thinking skills. So you come in and you've got these various lessons here, okay? And they start off pretty easy, okay? And it should be, you can see here, there's a time frame here of 30 to 45 minutes, okay? And that's from go to woe. That's pulling the kids out, getting them started. So in a 45-minute lesson, you should be able to get the kids to build whatever the model is and do the programming and finish up that activity. Now, you can take longer if you want to spend more time on it, and there's great merit in doing that, but it's up to you. If you 45 minutes is what you've got and you want to get that lesson done, that's the sort of time frame. Then they move into, so there's a couple of shorter ones like that, and then they move into activities that are a bit more involved. up to sort of, here's some which are 90 to 120 minutes, and then we've got 120 minutes plus. So, you know, much more involved, where there's less guidance and the kids really have to innovate and you know, do their own work to some degree. Okay, so we're inside the unit plans at the moment. Okay, and you can drop back and you can see, yeah, there's Invention Squad, Kickstarter Business, Life Hacks, and Competition Ready. So Competition Ready in particular is, as it says, it's about getting ready, you know, some units of work. We'll jump in. And you can download this software and load, you know, have a look at it. You know, it's free to download on the Lego Education Downloads website, and at any stage, and have a run through it. And you can see in here, there's a bunch of different activities, most of which you can use with the core set. In here, there are a few that require the add-on set, but they're sort of the more advanced ones. But the sort of simple ones like this, you can expand out. It says more. You get a little video of what it'll do, and it'll also up here tell you what you need required. And you can see there, it's just the Spike Prime, the basic set. But yeah, and you can see it's pitched at beginners, and it's aimed at Key Stage 3. Okay, so we'll come back in and we'll explore one of the other units in a moment. I'm just aware of time, that's all. So then we've got, so the guides in there. We've also got in here the build instructions. So most of the designs that are in the various units are here as well. For some people, they don't want a particularly structured lesson. They want to challenge their kids a bit more. So this is a great area. You come in, the kids can build a particular design. They don't get the, they get the instructions for the build, but they don't get the instructions for the coding. So some teachers have asked that it's a bit more open, if you like, where the kids build something and then they can work out how to program it without the sort of the scaffolding that you get in the unit plans. So this can be a great resource for you as the kids develop in confidence. Now, the other section is My Projects, okay? And this is where all the programs that the kids have created will be. And they can come in here. This is where you can come in and you can rename programs and delete the programs that are no longer wanted, that sort of thing. Okay, so you can see there, I've just gone in, jump out of there, jump back to the home section. So that was in My Projects. That's where I was a moment ago here. Okay, so if we jump back to, now we'll jump back into the units plans, and I'll go into one of the units in a bit more detail. So here we've got Invention Squad, okay? So this is about applying the engineering and design process. I guess one of the sections in the STEM that often gets overlooked or is not focused on as much of some of the other areas is in the engineering side. So there's the E in STEM is obviously engineering, and it's easy to hit the science and technology and the maths. The engineering is sometimes hard, and this is where the Lego Education products really excel in developing those sort of engineering skills, and it's one of the reasons why I think it's so wonderful. It's not like you know, some of the pre-built robots that you don't have any ability to, you know, it's always going to be a ball or a particular design. This, you know, you can design anything, and there's the models that are given to you. And then there's the opportunity for the kids to develop anything they like. And you'll see that when you go along to some of the competitions, you know, you see what kids have designed, and it's just fabulous. So jumping into the particular unit plans, we've got here, we'll jump into Super Cleaner. This one, Broken, I really like, and it's the idea that, you know, those of you, well, you're all teachers obviously, but those of you who have had the experience where the kids will build something, it won't work, either it's not built correctly, like some pieces aren't right, or the software's not right, whatever it happens to be, and they bring it up to you and they go, "Sir, it doesn't work. You know, can you fix it?" And it's like, you know, the whole idea, it's sort of in some cases lost on them that it's their job, if you like, to learn that process and to fix it and go back and review what they've done and try and work out why it's not working. And in this particular activity broken, if they've built it correctly, it doesn't work properly. And that's, so they've started off, if they've done that, they've had success. And then it's up to them to work out how to improve it, how to make it work properly, such that it runs smoothly and correctly, and work out whether they can refine it to improve it. And so I think that's a great little activity. One I'll show you now, we jump into this one, Super Cleanup, is it tells you here the things you need. So you're going to need the spike prime set. You're also going to need an empty plastic bottle, ball of crumpled paper, an apple or an object of similar weight. And it tells you it's in here. We've got a little video as well. It tells you this lesson will take 30 to 45 minutes. And we'll play the video. So just come up here. Okay, so you can see in that little video what's set out, what they're trying to do, if you like. Okay, so we jump in, we've decided, yep, that's an activity we want to do. So you jump in here to start. And it comes up, and here we've got this palette, okay? And this is where the kids will do their programming, or the programming will go. Okay, you can see I've still got the brick connected. It's come up and it's got a motor connected to port E and the color sensor. And we've got a restricted number of blocks here, if you like, that we can use. So it really narrows down what the kids have got available to them to assist them in sort of making sure they're finding it easy to stay on track and know what to do. If they decide they want to see more blocks, they want to add things in, you can always come down here. You've got the show all, and it expands out, and the full set of blocks are there, and they can jump back to show less. Okay. And so the tutorial, if you like, is over here where we've got you can see we're on page 1 of 8. And it will give these sort of, Lego follows the 5E teaching strategy, if you like. And in there, they're trying to engage students. The first one is E, is how to engage students. And you can see here, there'll be these sort of questions they'll start off with, like, did you see any rubbish on your way to school? And wouldn't it be great to organise a day of tidying up? And, so those sort of questions to try and initiate the engagement of students in that sense. So you can come down here, you might play them the video, designing something to pick up rubbish, that sort of thing. And then we've got a design here, and we can go in. We're on step 2 of 8 at this stage. And you can see here some instructions to build. Now, as I said, the build instructions are usually split up into 2 sections and the idea is that we don't always want the one child to be the kid who's building and the one child to be the kid who's programming. So here we've got it split up where we've got you might build the controller, if you like, and one student can start building the controller, and there's the instructions for that here. And you can see just building around that hub, okay? You can see these pieces, and there's a couple of new pieces in there, this bit known as the biscuit or whatever that Lego are very proud of, and you can see it allows you to build off in any direction very easily. So we've got this, okay. And there we're adding the pressure sensor there, and we're using a wheel as a little button for the pressure sensor, okay, to make it easy to use, okay. So that's the gripper, and you can see that would be stage 1 of a build, okay. Now, you can see here there are other steps, so someone else can take over and build gripper 1 or gripper 2, or they can divide it however they like. Okay, and there are instructions there on for building those. You can see you can just speed through those. Okay, and I can see it's probably taking a little longer with the through the video. Okay, and you can see eventually you get to a pretty close, a completed claw, which you can then attach to the control unit we were building a moment ago. Okay, now if we jump out of that, okay, and you can see here there's some instructions, you know, to connect the motor up to port A and connect the force sensor up to port E. So, and once that's done, you're essentially ready to go. And so rather than build it in front of you, you can see here I've got a little pre-built sample. And if I switch it on, okay, it's just come on. If we jump to the instructions there, okay, we're at stage 2 of 3. And okay, now it's saying to gather the rubbish that we're going to test these different claws out with that we've got. Okay, so things that we need: a Lego brick, an empty plastic bottle, a ball of crumpled paper, a stack of Lego wheels, that sort of thing, an apple or any round fruit. Okay, and you can see you can jump in here. Now I've got a little video that I'll play you as well of a little test that I did. Okay, and I'll just play this. I'll just shut off my video for a moment. So you can see here, we've got the gripper. Now you can see I've attached on one of the attachments, and I've got these items here, which appear as sort of rubbish that I could be picking up. So if I come along, grab the gripper, it's on, and start the program. Okay, and you can see as I press the button and release, you've got the ability to pick things up. So this is one of the grippers, and here's the second one, okay, that we can test. And students can build their own later on as well and design a better one. So we come along and we can test on picking up objects of different size and weight, and there's 2 different tests you can do. And so I might pick this up. You can see it did a pretty good job of picking up that brick, and we can place it in the rubbish bin. Come along, grab the green one again. Very easy to pick up. Pick up the paper. What do you know? Put it in the bin, and there it is. Oh, and then we find a little lint ball wrapper that I've obviously eaten, which we want to keep secret from my partner, so we'll clean that up and make sure she doesn't realise I'm the one who's eaten all the lint chocolates. Pop it in the rubbish bin. Now, if we go to pick up this particular set of wheels, it's very difficult, isn't so effective at picking it up. The apple, no good. Okay, so if we put our rubbish out again and swap over, and you can see with this particular model, just unhook it, pull it out, and you can attach on another set of claws really easily. I just plug in there, and away you go, and they're working straight away. That's, you know, it's a clever little model the way they've designed it, which you can attach on different claws and things. So when we go to pick up this time around, I'll try and pick up the piece of paper first. It does a reasonable job, it's not too bad. Try to pick up the little wrapper. It's not so good at picking that up, and you can see that in the test. Try to pick up these bits of Lego, not much chop. However, if we try to pick up these wheels, you can see it does quite a good job with that sort of, the sort of finger claw style that it's got. And it can pick up those, and you can see the students can test different types of claws. So, you know, say this apple, yep, it can pick it up, okay, you can see there, and you know, it does a pretty good job of picking up that sort of heavier. Certainly it's a lot better than the other claw design. Okay, we'll pop that in the rubbish bin, okay, and you can see, again, it's possible to get the paper, and we'll hide that. Okay, so that's an example of the gripper. The kids can obviously create better and improve these designs, and that's part of what they'd be expected to do. Okay, so to switch it off, just hold that down,
and that closes it down.
Okay. All right. So you can see there, that was a little sort of explanation video I put together just going through this activity. And so if we're now, you can see here the code that it's very simple code in this case at this stage. The way it's working, it's not using any of the, like the pressure of the, applied to the pressure sensor and linking that to the motors. It's simply switching on a stall detection and then determining whether the motors turn clockwise or anti-clockwise. And so very, in that sense, quite simple coding, but the activity itself opens up to sort of, you know, running experiments, recording data, manipulating that data. And you can see here, the first test to run would be testing the size, how effective the two different claws are at picking up a particular size object. And you can see there's a score, score that can be applied there. 1 if it grabs and lifts and moves the object, 0 if it grabs but drops the object, -1 if it doesn't grab or lift the object. And so you can make your way through, and the students would do that particular test. And then the second test would be about object weight. This time, how effective the two claws are at picking up heavy or light objects, that sort of thing. Then we've got, so the kids can draw a conclusion, and the final thing would be where they might create a video or something to record their learning process. And the other thing is, you know, as a sort of extension on the basic thing would be for them to design their own grippers that work better and might be able to pick up both heavy and small precise objects. And so the sort of engineering tasks that are available to them there are really, really quite promising. So that's a quick walk through one of the unit plans. If we jump back, you can see there's a whole range, and in life hacks, if we jump into that one, you can see there's ones that can help them move or read the weather. Go out to here, this one, which one is it? Rain or shine. We'll have it where it goes out and polls a weather server and can report back whether it's likely to rain or be sunny in a particular city, that sort of thing. So it moves towards gathering cloud data or Internet of Things sort of possibilities. All right, now that's essentially the software. You can see in there, it's where you start. Here's where the major units are. There's about, as I said, there's about 30 in there. And then there's some building instructions there and where your projects are. Now, you can go online as well in here in these sections. So you can go into teacher resources as well, and you can find more information online. So you jump in. So it asks you whether a teacher or a student. If you're a student, it just seems to reject you going there. But if you mark down that you're a teacher, it should take you off to this section. Yep, and screen's working correctly. Okay, now one of the things it will do, essentially in this area online, there's the basic unit plans are there, but there's also a lot of other information and resources available to you as well. So if we jump into life hacks, so I'll jump in, rather than going specifically into life hacks, you might jump into, might jump back into the software itself. Just a sec. Okay. And we're going to the one we were just in, so you can see what the difference is between the online version versus the one in the app. Okay, so if you remember, we're in Super Cleaner, so you can come into the teacher resources through there, and there's a number of ways you can get to the online section as well. It's also through the actual unit itself. But if we jump in here, now at the moment, one thing that's not obvious when you first come online is up here, they've got the, and they were supposed to change it in this, we wrote off to Lego and we were told it would be changed. but at the moment I notice it's still going to the, up here it's GB for Great Britain. You're best to change that to AU and then hit it again. And this time it will make sure it takes you to the curriculum links that are in there will be Australian curriculum links. So that's quite an important distinction. We thought that they would have fixed it in this update, but they haven't as yet. But we have had a commitment from them that they will fix it. So we might have to send off a reminder. But you come down and you've got these lessons in here for Invention Squad. Okay. And you can see here the super cleanup activity here. It seems to be loading slowly, which I'm not sure why. But anyway, so you come in here. This is the unit we were in before. I'll click, I want to go into that section. Okay. And here you can see at the top, there's a basic lesson plan. And you can see here they've got it's broken up into the 5 E's, which is to engage, explore, explain, elaborate and evaluate for the students, and as a guide for you and how long you should spend on each section. You've also got the key objectives here and things, but then you've got additional resources as well. And this is particularly useful to you. I'll just click in here. Okay, and expands out. Okay. And you can see here there are there's a test tables PDF. And so this, when you click on it, will come up. Sorry, it's slightly slow, but it'll get there. Okay, so these are the sheets that the students might use where they're testing the 2 different types of clause. That's the hard set of clause here, these ones. And then there's the other set of clause, which around here somewhere that I just can't seem to put my hands on at the moment. But the softer clause that you saw we're working with. And you know, they can put their ratings in here and work out the total. And then these are for the heavier objects and the lighter objects of different weight. Okay, and how effective they are in test 1 and test 2. So there's those resources there as well. Okay. And okay, and then you know there's a little guide here for how to ignite the initial discussion, sort of questions you might ask the class to get them engaged in the first place. There's the video. There's some building tips. Okay, and then you move down. There's some coding tips as well, and then you move into the areas specific for teachers, and it might be how you differentiate the object. The lesson itself. And you might take it to the next lesson, to the next level. There are also assessment opportunities here where teacher observation checklist, and you might have a self-assessment, you know, give the students the opportunity to assess themselves, or peer assessment, some guidelines there on what you might choose to do. Okay. And then we've got some other extensions into the language arts, how it might extend into maths. And then they've got this other one down here for career links, where kids who are particularly interested in this might be interested in certain things like a career in manufacturing and engineering, that sort of thing, or you know, business and finance. For some reason, they've got agriculture and horticulture in there. So they would, yeah. So there's all sorts of careers that might be the kids might be interested in if they found those sort of things interesting to build, create, use, that sort of thing. Okay, so there's a really great, there's some really great resources there that LEGO Education have put together to help support you in the classroom as the teacher. Now, we might jump back to I'm aware of the time, and so we might quickly jump back to the PowerPoint itself. And okay, and there's the breakdown of the different units and what they focus on, particularly, you know, computational thinking here, the engineering process here, programming with variables and data, and preparing for competitions, that sort of thing. Okay. Now, this is a little video that, one of the things that I'm not sure, just a sec, just make sure, oh, there is. Okay, back in, it is something that I forgot that is important, and I'll jump back to it because it's important. here, what I've forgotten is the educational standards here. In each of these lessons, they've been mapped to the Australian curriculum, in this case, the technology strand, and you can see there which sections they you can link them to as well. And so that's there for all the unit plans, which particular learning outcomes can be achieved with that particular lesson or unit. Okay, so my apologies, I missed that a moment ago, but it's important to go back to it. So we'll jump back to this bit. Okay, and this is the video of the my Make It Move. Okay, and I'll just. Okay. 1, 2, 3, go.
Ours is called the Destroy Box.
Okay, so you can see that they're in the face-to-face workshops I was talking about, and you can see there's a bunch of teachers who are all having a great time doing that little Make It Move hopper activity. And you know, you can see in there, if you look at the sort of when I was talking about play earlier and learning, and those 1, 2, 3, go. But you can see here, you know, was it joyful? Yeah, they seem to be having fun. Was it meaningful? Yeah, they're down on the ground, they're getting involved, they're engaged, it's iterative, and it's certainly socially interactive. And so you can see some of the simple tasks can be so much fun for the students. And this is just a reminder of those curriculum links to the various units. There you can see here ones that link to the activity called Going the Distance. Okay, there's another one, those ones for super cleanup. I don't need to labour over these, but you can see the ones for relating to help as well. And for some, okay, it's just going a tad slowly. It's gone into, there we go. Oh, there you go, it's raced through. All right, I might pull that up again because it's essentially, okay, it's completely disappeared off. I'll just pull the app up. Sorry about that. And it's okay. We're about to move. Essentially, we're about to move into the. I'll try and pull it up. Yeah, I seem to be having a little bit of trouble with my computer at the moment, so my apologies for that. We'll jump, or we might be able to get straight into this section. One of the things to know as well, hopefully it just, working with technology can always be a little bit problematic, so my apologies for any disruption there. But one of the things to know as well is that it's the Spike Prime's now got the option to code it in Python as well. So that'll increase. And initially I spoke about it, the target sort of market is 5 to 8, and where it fits in, I suppose, with the EV3. But it also, that they've introduced, you can program it in Python as well using the same app. So it's a really nice addition for those who are interested in that. And it'll probably extend it up beyond sort of year 8 as well. It'll have that potential. So yeah. Now at this stage, yeah, we'll go into questions and quotes. For anyone who, if you're looking for a quote, it's best that you go through your local school rep. If you're not sure who your local school rep is, then you can email me. I'll put my email address up on the screen in a little bit, and you can, and I can put you in contact with who your school rep is. Yeah, for quotes, it's best to go through your rep. We might also open it up to question time. So I'll just unlock Joanna and Chris so that they can come on and we can go through any questions. Chris, we've got unmuted. And Joanna, hopefully we can get you unmuted as well. Joanna, you should be able to unmute.
Well done, James.
Wonderful, wonderful. We've got you. So,
Okay. We only have one question that neither Chris or I could, I don't know the answer, and it might be that we just have to get back to Luke.
Yeah.
But it was if there's an option for students to sign in using Google Classroom and complete assigned tasks. It's not a question I've ever been asked before.
Google Classroom for what purpose? Sign into?
To complete their assigned tasks. So in other words, obviously, I don't know if Lucas would like to, have you allowed everyone to unmute themselves if they want to?
Not as yet, but I can do that.
Okay. Luke might like to add to it.
Okay. Yep, we might allow, yeah. So people will be able to unmute themselves now and jump on and ask any questions, or if you're a bit shy, you can type them in, that sort of thing. But yeah, Luke, are you able to jump in and elaborate a little bit more? We may not. Yeah.
So I was just wondering if they could use, if you could like assign those lessons or tasks on Google, like logging in through Google Classroom, so then they can like save it for later and the code later and things like that, because we do share devices at our school.
Okay. Yeah, I'm not particularly familiar with Google Classroom or how it structures or how it works in with the third-party apps in that sense. So I couldn't promise you, but yeah, we could look into it. But at this stage, we don't have an answer for you, unfortunately. Yeah.
No worries. Thank you.
Are there any other questions?
That was about it.
Yeah. You did such a good job. They didn't have any questions, James. It's all done.
Well, hopefully they're not too quiet. Yes, I'm happy to jump on. All right. We'll give everyone a couple of, we'll give them, I don't know, another 30 seconds or so. And if we don't get any questions, we might finish up.
Are these spike primes able to be used for like the Robo Cup and First Lego League competitions?
Yes, yeah, absolutely. So both competitions will open them up and allow you know, the spike prime used in them. Absolutely.
Oh, there's a question about the EV3. Can you use Scratch? So the EV3 programming is actually changing to exactly the same as the Spike platform. So with the new update of Windows version, which will be out later this year, then it will be changing over to that. And the Catalina, if you're on Mac OS, then the Catalina version, the update's already there for you to use. So that was from, and I don't believe it's Mac, or I do believe that she told us your name earlier.
Yeah, so just to clarify on that one, as the operating...
Sally.
Sorry?
Sally, the name, I think it was Sally that asked the question.
As operating systems move to a 64-bit operating system, Lego have decided that they're not going to update the current Lego programming language for the EV3, and they've instead released one that's quite similar to the Spike, which we more sort of Scratch-based programming for the EV3. However, if you stay on, there are some advantages to staying on the current programming platform. If you can stay on Windows 10, you don't have to change, or you don't have to update. So there are some people who are on the Macs who are being sort of more or less forced to jump to the newer version of the EV3 programming. So there is a distinction there, and some people may want to stay on one over the other, but it's, it's up to you. All right. Any other questions?
No, I don't think so. Good.
Okay. Well, in that case, thank you very much, everyone, for your time. I hope you got something out of it. As I said, did say that I would type in my email address if you need to contact your rep. I'll just do that quickly. So I should be able to do it from here. I'll type it into the message function. So that'll go. So it's, yeah, jdwyer@teaching.com.au. All right. Okay. Oh, so we got Danielle Sims has asked, I'm so worried about kids being careless with putting pieces back. Okay. For Danielle, there is a guide. So in the trays, I'll just see if I've got, I haven't got one here, but I'm not sure. I'll just pull up the video so I can see what you guys are actually. So on the trays, there are little stickers there about what pieces should go in each particular tray. So in a kit, you'll get a guide, this sort of laminated card to overcome that issue. In the kit itself, you've got this laminated card that indicates what pieces should go in which trays, okay? And there are also stickers on the sides of the trays there. So hopefully you can see it. I don't want to tip everything out of here, but there's a little sticker there which indicates what pieces should go in what particular trays, and anything that's not assigned a tray on these cards is what would sit in the box underneath. So it comes in a hard plastic tub, a bit like that, okay? And you can see one of the trays in at the top there. So hopefully that will assist with a guide for the students for, you know, where they should put the pieces, that sort of thing.
You hope.
Indeed, indeed. Okay. Okay, well there you go. There's a great
Good answer.
yeah, from now it's from Hatzimka. Sorry if I've got that pronunciation incorrect, but and the person said what we do is provide an extra box for the robot, then we color code each spike box so pieces don't get shared. So there you go. Yes, there's different ways to solve it, I suppose. Yeah. Thank you for that feedback. And they label the robot too. Very good. Okay. And if there's nothing else, we've dropped down. We've got, looks like 22 people left. So we probably drop down. We might finish it up. Okay. Thank you everyone for your time. And yeah, we'll be running other workshops. I think next week, Joanna, you've got a We Do.
Yeah, New Zealand Spike and a We Do.
Wonderful, wonderful. Look forward to that. Okay. Thanks everyone. Bye.
Okay.
Thanks,
Bye.
guys.